Welcome to the deep dive. We sift through the noise, the research, all those sources to bring you the essential knowledge you need in this, well, constantly changing world.
And today, we're looking beyond just where AI is right now. We're really pushing into the next decade, looking at this huge shift in abstraction, moving past specialized AI towards maybe artificial general intelligence, or at least systems that think and act much more autonomously.
Yeah, the sources you pulled together, they really paint this powerful, consistent picture of what's coming. So our goal here for this deep dive is to unpack how the next 10 years or so could totally redefine software, right? And what skills you'll actually need, and maybe most importantly, what's the human role in this? What the sources are calling the post-code era.
Right, and it all really hinges on one core idea.
Yeah.
We're shifting from programming code to programming intent. That's the big one. It's probably the biggest leap in hiding the complexity since the internet itself arrived. We're talking about communicating concepts, not just syntax.
And that connection, that's crucial for you listening, whether you're running a business unit, building something new, or just planning your own career path. I mean, if the very way we create digital software is flipping on its head,
Then everything changes. Roles, workflows, business models, it's all going to transform probably pretty fast over the next 5, maybe 10 years. Getting your head around this now, that's the key to leading, not just reacting.
Okay, so let's trace that path. Looking back helps understand the jump we're making now. The sources map out this journey of abstraction in software. It starts, like, way back in 1995.
Yeah, that's the classic starting point. Netscape Navigator arrives. Suddenly there's this window onto the web, fueling e-commerce streams. But remember, that early web, mostly static pages, like digital documents.
Right, not much happening dynamically. The code was simpler then.
Much simpler, and tied very closely to the specific machine it ran on, very little abstraction.
But static didn't last long.
No way. The big milestone was Java, around 97. Write once, run anywhere. That was the promise. Suddenly, software wasn't tied to the hardware anymore. That's what enabled scale, mobility, complex business apps. It laid the groundwork.
And then the layers just kept piling on, microservices breaking up the big apps.
Right, into smaller independent bits, then serverless, where you kind of stopped even thinking about the servers themselves.
Run somewhere.
Exactly. And you had blockchain for trust, IoT connecting things, RPA automating simple tasks, and of course cloud computing, turning everything into an on-demand utility. Each step pushed the programmer further from the machine code, closer to the business problem.
So it's like we went from telling the computer what math to do to telling it where to do the math to eventually just saying, do the math, I don't care where or how.
That's a great way to put it. We kept shifting the hard parts, the complexity, away from the human developer. Managing physical servers became managing serverless functions. Manual DevOps became AI-assisted AI ops.
Okay, but this current shift, the AI native one, feels different somehow.
It feels profoundly different because it's not just about making existing code run better or faster. It's starting to automate the creation of the software itself. Previous leaps were about efficiency and scale. This is different.
We've hit some kind of turning point?
I think so. It feels like we're moving towards a nonlinear future. The system itself starts generating its own logic, its own structure, based on the goals we give it. So the software isn't fixed by a human coder anymore. It's flexible, adaptive.
Okay, that leads us right into this near-term wave, let's say 2025 to 2030. The sources say the big idea here is AI graduating from just being a co-pilot, helping out,
Right, suggesting the next line of code.
to being a full collaborator that actually helps build the thing. AI native development becomes like the standard way.
Yeah, and that distinction is really important. Today's copilots speed up coding. But the human still defines the architecture, the detailed steps. An AI native collaborator lets the user just describe the objective, the intent, instead of how the code.
Which leads to some really wild-sounding ideas in the sources, like prompt as source. So no more Git tracking every single line change.
Well, maybe not no more, but it'll be supplemented definitely.
Right.
These next-gen AI development environments, they won't just track code diffs. The real source of truth becomes the prompt you used and the test results you got from the system it generated.
Okay, hold on. If the prompt is the source and the AI spits out, I don't know, 1 million lines of code, isn't that a massive black box? How do you debug that if something breaks? You can't just read the code like before.
That's the central challenge. Governance, explainability. These systems have to be built with observability baked in from the start. We're swapping manual debugging for AI verification tools. The developer's job changes. It's not about finding syntax errors anymore.
It's about.
It's about making sure the prompt and its constraints were right, making sure the lineage of the generated code is clear. So if it fails, the AI can tell you which prompt version or what input data led to the bad output. You're debugging the intent, not the code itself.
Debugging the intent. Okay. Now, related to intent, vibe coding. That sounds cool, but maybe a bit fuzzy.
It does sound a bit artistic, right? But it's the logical result of really good natural language understanding mixed with deep context. Think less programming, more like technical art direction. You stop writing the boring stuff, the boilerplate to connect APIs or set up a UI.
Instead, you just describe the vibe.
Kind of. You describe the functionality you need, but with rich context, like, I need a dashboard for Q4 leads from Salesforce, make it look minimalist, mobile first, and alert me if conversion drops below 15%. Very specific but natural language.
And the system just builds it. Scaffolding, API calls, UI logic, everything.
That's the idea. Handles all that grunt work based on your high-level request. A human focuses on the critical business rules, the user experience, not the syntax.
Which frees up time for more complex things.
Exactly, which enables the next step, agentic programming, where it's not just one big AI model, but a whole team of specialized AI agents working together.
Okay, now that sounds like we're stepping towards AGI territory. Autonomous agents reasoning, coordinating.
Yeah, this is where it gets really interesting. Instead of one developer, you define a goal, and the system deploys, like a digital team. One agent designs the database schema securely, another handles authentication, a third builds the UI, a fourth does load testing.
And they talk to each other.
They coordinate based on defined contracts and constraints set by the human architect. It turns development into orchestrating a team of digital specialists.
Wow, okay, but orchestrating all that needs serious computing power, right? The sources were pretty clear on this. The demand for compute and energy is forcing a hardware rethink.
Absolutely. It's a fundamental bottleneck. The scale of these AI models, the constant training, current general-purpose chips, CPUs, GPUs, they just can't keep up affordably or sustainably. So we have to specialize.
What does that specialization look like?
It means custom silicon. AI-specific chips designed just for certain types of models, like transformers, or domain accelerators chips optimized for specific tasks, like fluid dynamics or computer vision in a warehouse. Compute's getting fragmented, very custom.
And it's not just happening in huge data centers, is it? The sources talk about hybrid architectures.
Right, we're moving beyond just the cloud. Future systems will blend everything seamlessly, big cloud power for training, maybe local data centers for core stuff, and definitely, crucially, computing happening right out at the edge.
Edge inference. Why is that so important?
Two main reasons. First, speed. Low latency. If you have an autonomous car or a factory robot, it can't wait for a trip to the cloud to make a decision. It needs to happen now.
Makes sense. And the second?
Privacy and security. Sensitive data, like medical info or defense applications, you often can't or don't want to send it off the device or outside a secure area. So the AI reasoning, the inference, has to happen locally, right there on the edge.
So the infrastructure itself needs to get smarter, more adaptive.
Totally. Infrastructure planning is moving away from humans setting configurations to AI doing continuous self-optimization. The system itself manages resources, CPU, memory, network, even deciding cloud versus edge optimizing for cost, speed, reliability, all on the fly based on the intent you set.
That idea of self-optimization leads straight into reliability and governance. If these systems are building and managing themselves, then self-healing isn't just nice to have, it's essential.
It's the absolute foundation for trust. That's where advanced AI ops comes in. Continuous monitoring way beyond basic metrics. Detecting anomalies in generated code or system behavior, automatically scaling up and down, fixing things automatically when they break, often before human even knows there was a problem.
The sources mention SLO-driven governance, service-level objectives. How does that work when an AI is building the system?
Okay, so an SLO is basically a formal promise about performance or reliability, like 99.99% uptime or average response under 50 milliseconds. In an AI-native world, that SLO isn't just a goal for humans to aim for. It becomes an automated constraint for the AI.
So the prompt isn't just build this app, it's build this app and it must meet SLO X even at peak load Y while keeping costs under Z.
Exactly. The AI has to solve that complex optimization problem, where reliability is a hard requirement it has to design for. It makes reliability a compliance issue, not just an aspiration, which becomes even more critical when you think about shadow apps.
Right, the governance headache. What are shadow apps exactly?
They're kind of the risky side effect of AI becoming easier to use. Imagine powerful tools, automation scripts, data analysis models being built by people without a technical background using these new AI capabilities,
Mm.
often completely bypassing IT oversight or security checks.
And because they might access sensitive data or automate important workflows?
They create huge potential risks.
Mm.
Security gaps, compliance issues, no audit trail is where we're entering what the sources call the governance era.
So what does that demand?
It demands transparency, knowing why the AI did what it did, explainability, being able to articulate the system's logic clearly, and comprehensive audit trails for everything the AI generates, tracing it back to the prompt and data. Security, DevSecOps, it all has to become AI aware, focusing less on checking code lines and more on validating the system's intent against policies.
Okay, so if AI native is the near-term default, what does that mean for people, for work? The sources stress this isn't about replacement, but co-creation. AI agents as teammates.
That shift in perspective is maybe the biggest mental adjustment needed. It's moving past the fear of replacement and seeing AI agents as super specialized colleagues. One handles data cleaning, another checks regulations, a third optimizes logistics. Humans provide the strategy, the judgment, the ethics.
The sources call this mixed initiative systems.
Yeah, that's where machines and humans work in this continuous loop. The machine gives speed, scale, data access. The human brings nuance, sets goals, handles tricky emotional stuff, makes judgment calls algorithms can't. The initiative can flow either way. It's a real partnership.
And this changes what software even is. We're not just building apps anymore, but ecosystems of agents.
That's the architectural future, it seems. Instead of one giant program, businesses will assemble these modular digital workers. They collaborate through contracts and goals. Like one agent monitors customer feedback, flags an issue, triggers another agent to suggest a solution, which then tells a third agent to update the customer record.
That modularity leads to this idea of an agent marketplace, like an app store, but for AI workers.
Exactly. Companies won't have to build every specialized agent themselves. They could buy or subscribe to pre-trained, validated agents for specific tasks, say, an agent certified for GDPR compliance, or one optimized for pharmaceutical supply chains, or one trained on successful marketing campaigns. It drastically lowers the barrier to using complex AI.
And if you're buying agent services based on what they achieve, the sources say this leads to a huge shift in business models towards outcome-based pricing.
Yet this could really change how we pay for technology. Why pay a flat subscription or per user when you can tie the cost directly to the value created? If you deploy a security agent to stop fraud, maybe you pay based on the fraud it actually prevents.
So the risk shifts more to the AI provider. They have to deliver the promised outcome.
Precisely. It forces them to guarantee performance. If your scheduling agent books 100 qualified sales calls, you pay for those calls. If your compliance agent verifies 5,000 documents correctly, you pay for that specific outcome. It links tech spending directly to business results. Executives will love that.
Okay, if you have these autonomous agents writing code, managing money, taking actions in the real world based on intent, everything depends on trust, right? Safety and ethics become absolutely critical.
Non-negotiable. When the system assembles itself, the chance of unexpected or harmful behavior goes up. So trust isn't just a feature, it becomes a key competitive advantage. Customers will choose the platforms they believe are the most transparent, responsible, and auditable. Trust is the new killer app.
So what needs to be built in? What are the non-negotiable safety features?
Multiple layers. First, formal validation. Before an agent does something significant like deploying code, a validation layer checks the plan against all the rules and policies. Second, runtime safeguards, real-time checks that stop the agent from violating safety boundaries, even if its internal logic thinks it's okay.
And the human escape hatch.
Absolutely essential. Human override capability. A supervisor must always be able to step in, pause, or undo an agent's action. And finally, rock-solid governance and auditing built in, tracking everything. The intent, the agents involved, the data used, why the action was taken. A perfect, unchangeable record for compliance.
Okay, let's look further out now, beyond 2030 into this post-code era. The sources see software and AI models fully merging. We basically stop writing code in the traditional sense.
Right. We end up with what the sources call behavioral systems. The human interaction moves completely to defining the objectives, the constraints, the ethical guardrails, and the system dynamically figures out how to achieve those goals, assembling itself from libraries of models and code snippets.
So we're creating intelligent systems that manage their own behavior based on high-level goals, not fixed instructions.
Exactly. And this is enabled by some advanced tech trends, things like neural symbolic hybrids, combining deep learning's pattern recognition with classical AI's logic and reasoning. That way, systems can be both smart and provably follow rules, which is vital for areas like finance or medicine.
Makes sense. You need both intuition and rules.
Yeah, and we'll see mixture of experts models becoming standard. Instead of one giant AI, tasks get split among many specialized AI components, working together more efficiently and accurately.
And these systems aren't static, right? They have to keep learning.
Continuous learning in production will be the norm. These systems will self-optimize, maybe even safely rewire themselves, update their own logic, their knowledge, as they encounter new data or changing conditions, but always staying within those human-defined guardrails.
If systems can do that, then agent-native businesses seem like the logical conclusion.
Seems inevitable. Imagine a company where almost everything planning, resource allocation, customer service, product updates is handled by collaborating intelligent agents. Human leadership focuses entirely on setting the overall strategy, the goals, and ensuring the whole agent ecosystem is aligned ethically.
Right, this brings us to the skills. This is the critical part for everyone listening. If developers, managers, leaders are becoming system conductors, not code writers, what skills should people focus on now?
It's a demanding new set of skills, definitely a departure from just knowing programming languages. It's about orchestration, modeling, thinking in systems.
Okay, let's break down these competencies from the sources. This is the actionable stuff.
First up, prompt engineering and orchestration. And this is way beyond just writing one good prompt. It's designing complex chains of prompts, coordinating multiple agents to hit a big goal. It's like being the architect of the intent itself.
Then the big picture view, multi-agent architecture and reasoning.
You have to understand how different specialized agents, maybe with different permissions or data access, can work together safely and effectively. That means knowing about communication protocols, safety contracts between these autonomous bits.
And the foundation for control, schema policy and constraint modeling.
This might be one of the most valuable skills, even if it doesn't sound like AI. It's the ability to define really clearly and without ambiguity the objectives, the rules, the limits the system must follow. Like writing formal contracts the AI can understand and obey.
So you're writing the rules for the solution, not the solution itself.
Precisely. Other key technical skills, AI system security and lineage tracking, being able to trace AI-generated code and find vulnerabilities. Observability and self-healing design building systems you can monitor and that can fix themselves.
What about people who aren't deep techies? Business professionals.
They need low-code collaboration and domain fluency. Being able to clearly explain complex business problems to the AI in natural language becomes incredibly valuable. If you can't define the problem well, the AI can't help you solve it. Also, things like compute optimization awareness, understanding the cost implications, and definitely AI governance and regulatory literacy.
That's a lot of technical skill, but the sources also really emphasize a fundamental mindset shift being even more important.
Yeah, this is the deep change. The old way of thinking for a developer was deterministic. Input X, function F, guaranteed output Y. If Y is wrong, debug F, simple.
In the postcode era.
Totally different. You have to think probabilistically. You define objective Z and constraint C. The system finds the best path to Z, maybe using millions of steps you can't even see. Your job is designing for that probability, making sure that no matter which path the AI takes, it stays within constraint C. You design for possibilities and acceptable risk, not for perfectly predictable steps.
So defining what success looks like, and crucially, what failure isn't allowed to look like, rather than dictating the how.
That's the core idea. It means building things differently to more modular, designed for uncertainty, with fallback plans and iteration baked in from the start.
Okay, so if you're looking ahead strategically, where should people maybe place their bets? What areas look set for growth?
You look at where this shift creates new needs. Agent orchestration platforms and marketplaces, tools to manage and trade these agents. Domain-specific vertical agents, AI solving very specific industry problems with guaranteed results. Edge AI and hybrid compute systems because compute needs to be smart. AI verification, audit, and explainability tooling, huge need given the governance issues. And human AI collaboration platforms, the tools that manage that interface between us and the machines.
Makes sense. But we can't just talk about the exciting future without acknowledging the bumps in the road.
Oh yeah, every big tech wave hits friction. It's important to be realistic about the roadblocks that will slow this down.
What are the main ones the sources point to right now?
Well, The list is still pretty fundamental. We still struggle with AI hallucinations, AI making stuff up confidently, and brittleness, where systems just break unexpectedly. The compute cost and energy use is still a massive practical barrier to widespread, profitable deployment.
And the legal and security side.
Big challenges there. Regulatory gray zones. Who's liable when an autonomous agent messes up? The user,
Yeah.
the developer, the model creator. That uncertainty slows things down. And data security and adversarial attacks are getting smarter, targeting the AI models themselves.
Plus the people factor.
Absolutely. Cultural resistance is real. People worry about jobs or they just don't trust systems they can't fully understand. And technically, just integrating these new agent systems with decades of messy, old legacy software, that's a huge, expensive headache for many companies. But these frictions aren't necessarily bad. They force innovation in safety and governance.
Right. And despite all this power, the agents, the self-healing systems, the sources keep coming back to the human element, saying we're still the key.
The human core is indispensable, yeah. AI can mimic empathy or creativity, but it doesn't possess them. Humans provide the ethics, the deep domain knowledge, the emotional context, the creative spark that defines what a valuable outcome actually is. Without us setting the real intent, the AI is just number crunching.
So our job in this postcode world isn't to step aside, but to become better conductors.
Exactly. Our role is aligning the tech with our high-level goals, not just writing syntax. We become masters of defining the boundary, the values, the purpose within which these incredibly powerful systems operate, making sure the intelligence serves human aims.
So wrapping this deep dive up, it really feels like a fundamental software revolution. The big shift, as the sources put it, isn't about the act of coding anymore. It's about specifying intent, defining those non-negotiable constraints, and skillfully supervising these agent systems as they evolve hopefully safely, ethically, and intelligently.
Right. If AI handles the syntax, the human job becomes taking care of the soul, the purpose, the ethics, the consequences.
So, our final thought for you to take away as you prepare for this more probabilistic future. If AI handles the technical how and we handle the ethical why, what's one specific non-technical ethical constraint, maybe around fairness or transparency or bias, that you could practice defining clearly today? Think about how you turn that abstract value into a concrete rule a machine could actually follow, preparing for a world where systems build themselves based on your intent.
How do you make responsibility computable? That's the challenge.
Something to think about. Until next time, keep diving deep.